Alright, this is lesson 106 for Algebra 2, solving logarithmic and exponential equations. So, I want to bring us back to our last lesson. Something you need to know, just turn your groups really quick. What would you do with this 3? What's something you could do that you learned last week that you could use a property on this 3? What's one thing you could do with it? Talk to your groups really quick. 10 seconds. Okay, what can we do with that 3? Move it where? To the front, that's right. We can move it to the front, right? We could say, oh, it's not, we don't have to put it as an exponent. We could say this is 3 times log base 10 of 4, right? So we want to know that. We want to know the different, properties, because we want to be able to provide or to use them sometimes when we need to work out the problems, okay? So today we're going to be solving. Whenever we see the word solve, we need to find what's the letter, okay? Solve means we have an equal sign, and we're asking what's the letter equal to, okay? Good? All right. So those are the steps. If you're on the video, you should pause the video and write them down. Okay, let's continue on here. So, number 1, solve. We want to figure out what the letter is. So the letter in this case is B. It says 6 to what power? 6 to the B power is equal to 35. Now I know that 6 squared is equal, or 6 to the second power is 36, right? But this isn't 36, it's almost 36, right? So I could estimate an answer, right? What's a good estimate that I could use? We're thinking exponents, not... Don't you think 2 is a little too big? I heard someone say 1.9. I think that's a really good estimate, right? Because 6 squared is 36, right? But we're not going 6 squared. We want to only go up to 35, right? Does that make sense?
Yeah.
Okay. So I'm sharing that you want to estimate your answer so you think ahead. You don't want to like get there and be like, you just want to pretend like you got the right answer. You want to try to estimate it if you can. Okay. So I'm thinking it's going to be 1.9. So how does this work? So the nice thing about logarithms is that we can use them in exponential equations. So when I'm trying to solve and there's a variable in the exponent, I could get this variable in the exponent out using a logarithm. Okay? Once the exponential term is by itself, I could do this thing called take a log of both sides. Okay? And I want to use log base 10, or common log, because that's what's on my calculator. Okay? Or I could use log base 2. Some people have that on their calculator, log base E, or natural log. Okay? But you could take a base of anything. Sometimes you want to take a log base 7, or sometimes you want to take log base 6, because this is a 6. Okay? But in this case, let's just use common log. So I'm going to take a common log of both sides. I'm just adding log to both sides, so I'm changing it up. Okay, and with that, you see how it's common log of 6 to the b power? What can I do with this b now? What can I do with this b now? Move it to the front, right? Just like I told you a minute ago. So it's like b times log base 6 is equal to common log of 6 is equal to common log of 35. Okay? So, I want to get b by itself, so I'm going to divide both sides by common log of 6. Okay, so now we're at the end. So b is equal to log of 35 over log of 6. Okay, so this is an appropriate answer to do on a test, okay? This would be an answer I could take on a test, because I wouldn't let you use a calculator. Does that make sense? But since we have calculators out now when you do your AMs, I know you could go on like Photomath or Mathway, and you can get the answer too that way, but you need to know how to do it anyway. So here we go. Get your calculators out.
Here's an iPad.
Or your iPad, whatever you like. Okay, so but the first thing you want to do is clear out your calculator. So let's press the clear button, okay? And we're going to start with the numerator. We have log, our common log of 35, so we're going to press 35, and then press the common log button. That's how much the numerator is worth. Then we have the fraction bar, which signifies divide. And we have common log of 6. We're going to press 6 common log, gives us the common log of 6, and press equals, and you get this answer 1.9842, right? Oh, I forgot to put the 1. There it is. Okay. And I could, when I look at my calculator, I want to make sure round. I'm looking at this 4 on the calculator. It says a 2 next to it to the right, so I want to keep the 4 the same. Okay? So that's number 1. Okay? Number 2, same idea. Now, this one's a little bit harder, right? Because we have, the left side is not isolated. We have x is my term I want to, or the variable I want to solve for. And then I got this 37 is minus 3. So I want to combine like terms before I even start. So I'm going to add 3 to both sides because I want to start solving it. Okay, so I'm adding 3 to both sides. You got 17 to the 2x is equal to 40. Okay, and you're like, man, that's still hard, right? I know 17 to the first power is 17, so then the second power is like, whoa, it's big, right? It's like 200 or 300, right? 300 or 400, right? So we need to do something with this. So since the exponential term is by itself, I'm going to take a log of each side. What base should I use? 10, right? Common log. Why? Because what's on our calculators? Common log, right? So we're taking the common log of both sides. So I'm taking a common log of both sides, okay? Now what can I do with that 2x? Bring it over, right? We got 2x times the common log of 17 is equal to the common log of 40, okay? And I want to get the x by itself, right? So think about this. This is like saying 2 times x times common log of 17, right? Y'all see that? 2 times x times common log of 17, yes? Okay, good. So I want to get the x by itself. So everything that's being next to the x is being multiplied. So what's the opposite of multiply? Divide. So I'm going to divide both sides by common log of 17. And I'm also going to divide both sides by common log of, or I'm sorry, not common log, just 2, okay? And when I divide both sides by 2, we're going to put the 2 on the denominator here, and we're basically multiplying, right? So we got 2 divided by 2 is x, and then common log of 17 divided by common log of 17 cancel out. And then we got common log of 40 divided by 2 times common log of 17, okay? So common log of 2 times common log of 17 is its own parentheses now in the denominator. Okay, so this is like saying 2 times common log of 17. Uh-oh, that's kind of scary. Not really. Ready? Let's pull out our calculators. Okay? Okay, so I'm going to teach you about these memory buttons that are on the calculator. They're very important to use sometimes because you have to do calculations in a certain order. Remember, orders of operations. So let's clear out the calculator and then also press the MC button, which means memory clear. Okay? Here we go. We're going to do the denominator first because it's in its own parentheses. We have 2 times the common log of 17, so we're going to press 17. Press the common log button and you get this number. And then we're going to multiply that by 2. And we get this new number, 2.4608 something, right? So now we're going to press the M plus button. We want to save that. So we're going to press M plus. And now that's recalled into our memory, okay? Now we're going to press the C button once. Just the C, not MC, but C. Okay, now we're going to do the numerator. So we got log of 40, so we push 40. We're going to press the common log button. Then we're going to press divide. And then we want to divide by the amount we just saved because we just calculated it. So we're going to take, we're going to do memory recall. So after we press divide, press MR. Okay, that's the number we remembered. And then we're going to press equals. And we get a number. You should have had 0.651 as your answer, okay? Y'all got that, right? That's it. That's how you do numbers 1 and 2. Any questions on numbers 1 or 2? Yes, sir?
So without the calculator, then the answer before that would be the answer to the test.
That's right. Absolutely. Good question. Okie dokie. Okay, moving on to number 3. Okay, number 3. We got 14 to the n power is equal to 52. Okay, so Do we know 14 to what power is equal to 52? No, we can't. So we could use logarithms. So look at number 1 and work with your neighbor to figure out what you would do in this problem to work it out. Okay? Go. So you should have taken the log of both sides, yes. And then you got common log of 14 to the n is equal to common log of 52, yes. And then you got the n you're going to bring down to the front. And then you got to divide both sides by common log of 14. And then you got one foul swoop. You're going to write common log of 52 divided by common log of 14. And your answer is going to be, anytime now, okay, 1.497 is correct, okay? There you go. Very good. Number 4. Go. This one's going to be, you have to start off by, notice it's saying -8 times 10 to the 4x. It doesn't say -8. You're not subtracting anything. It's -8 times. Okay, go. I'm just noticing some people didn't divide by -8. You should have divided by -8 first. Right? So you should have 10 to the 4x is equal to positive 19 over 8. Keep going here. Is x is equal to 19 over 32. Now I got a question for you. You see how I took the common log of both sides? What's the common log, or you see how I brought the 4x down to the front, right here? You all see that? What's the common log of 10 equal to? 1, right? So this side is just 4x. Divide both sides by 4. I'm really dividing, or I'm going to divide by 4, which means I'm just going to make the denominator multiplying by 4. So it's 19 over 32 is the answer. Okay? Yeah? Number 5. Okay? Now I got a question for you. Don't get worried. Number 5. Oh man, what am I doing here? Now I got a question for you. You know how like the beginning of the problems look like this, and then I could take a log of both sides? What if I started with logs? Can't I go backwards and erase them? Does that make sense? Not like number 1, you know how I added a log of both sides? What if I had a log of something equal to a log of something? Couldn't I take them away also? Yeah, we can. So this one you could just take away the logs. When it's a common log of something equal to the same common log of something, then you could just erase the logs. Does that make sense? Okay, so it was the idea like the exponents with the same base, we can make the exponents equal to each other. Here's the same type of logic, okay? So this is now a pre-algebra problem. You can finish this one up. Here, go. -2 is correct. Okay, next one. Number 6, log base 9 of 4x minus log base 9 of 2 is equal to 2. What do you notice about this problem that's already different? Log base 9, okay. What else do you notice? It cancels out? What do you mean? Not quite. We have a negative sign there. That is a hint. You're on the right track. What would you do with that negative sign? That minus sign. Think about last Friday. We had expanding and condensing. Expanding, condensing. How would you condense? Turn to neighbors. That's your hint. How would you condense? Can you subtract logs?
No.
Can you condense logs?
Yes.
Do my logs have the same base of 9? Okay, good. Watch. Ready? Since we have the same base of 9 on the left side, let's condense them. Remember doing this on Friday? Do you see what I just did there? You see? Huh? Huh? Where are you lost?
Everything.
No, you got this. You see log base 9? These both have log base 9. I just condensed them into one log base 9. Remember the quotient property, 4x minus 2? It's, you use a division sign when you see a minus. Are you here on Friday?
Yeah.
This was Friday's lesson. If you don't get this, you have to go back to Friday's lesson, okay? Alright, so now we bring down equals 2. Alright, so, you see what just happened? Okay, now we can convert this to an exponential equation. So we got 9 to the second power is equal to 4x over 2. And then we could work it out. 9 squared is equal to 81. Multiply both sides by 2. We get 162 is equal to 4x, so x is equal to 40 and 1/2. Okay? It's kind of hard?
Yeah.
Okay. Alright, so I'm going to stop the lesson there. We got some practice.